Welcome to The Explainer. We're going to kick things off with a pretty wild contrast today. When we look in the mirror, it's so easy to think of our bodies as being built out of these massive structural blocks, right? We see bones, huge muscle groups, we know we have gallons of blood pumping through us. But the reality of our biology is actually far more delicate. It's the microscopic trace elements that act as the true linchpins holding all of that massive biology together.
So it begs the question, right? What actually happens to our massive, complex physiology when we're starved of nutrients that exist in only the absolute tiniest of quantities? You might assume a small deficiency just means a small problem, but in the highly regulated world of human homeostasis, that couldn't be further from the truth. Just to get us all on the same page, let's define our terms. Trace elements are nutrients required in absolutely minute amounts by the human body. But make no mistake, they are non-negotiable, essential cofactors for survival. They regulate our enzymes, they build our structural proteins, and they arm our immune systems. Without them, our biochemical machinery literally just grinds to a halt.
So here's our roadmap for today. We're going to start with the power of trace elements, then move into iron, our oxygen carrier. After that, we'll check out zinc and copper, dive into selenium as the heart protector, and wrap the whole thing up with iodine, the metabolic engine. All right, part 1. The power of trace elements, our microscopic linchpins. So there are exactly 5 major trace elements and their deficiency states that we're zooming in on today. And honestly, the rule of thumb here is absolutely unforgiving. Lacking any single one of these 5 triggers dramatic multisystemic physiological consequences. It isn't just some minor inconvenience. We're talking about a complete domino effect of cellular failure. Moving right along to part 2, iron, the oxygen carrier. Getting dietary iron from your gut into your bloodstream is just this incredibly complex, choreographed cellular journey. First up, an enzyme called D-Site B chemically reduces dietary iron into a usable state. Then, a transporter called DMT1 pulls that iron right into your intestinal cells. Finally, ferroportin, which is the body's only cellular iron exporter, ships it out into the blood plasma. It is molecular teamwork at its finest. Now, here's the crazy part. Your body literally has no active way to excrete excess iron, which means all the regulation has to happen right at the door. And that's where hepcidin comes in. It's a hormone secreted by your liver that regulates this entire process by binding to that exporter we just mentioned, ferroportin, and degrading it. Hepcidin effectively acts as a microscopic bouncer, either trapping the iron inside the cells or letting it flow freely into your bloodstream, depending on exactly what your body needs. This is where it gets super interesting. We really have to separate true iron deficiency from the anemia of chronic disease. In a true deficiency state, your iron stores, which we measure using a protein called ferritin, are completely depleted. But in chronic disease, systemic inflammation causes your liver to just pump out hepcidin, which persistently traps your iron in storage. So you have the iron, it's in there, but your microscopic bouncers simply won't let you use it. All right, on to part 3, zinc and copper. So zinc and copper have incredibly distinct roles in the body. Zinc is this vital metal enzyme cofactor, and lacking it leads to severe acrodermatitis-like skin conditions. Copper, on the flip side, is absolutely essential for cellular energy. A lack of copper, which is often due to a genetic defect in the ATP7A transporter, leads to Menkes disease. This causes devastating neurological issues, which just goes to show how critical this tiny amount of metal is for our brain health. Looking specifically at a zinc deficiency state, it's fascinating. Sure, without it as an enzymatic cofactor, you're going to suffer from poor wound healing and immune impairment. But maybe the most surprising symptom is hypogeusia, which is the loss of taste. Just think about that for a second. Missing a microscopic metal directly robs you of the incredibly relatable human experience of just tasting your favorite food. Next up, part 4, selenium, the heart protector. Think of selenium as the ultimate sidekick. It acts as an essential antioxidant cofactor for an enzyme called glutathione peroxidase. Without selenium, this enzyme is totally useless, which leaves your cells highly vulnerable to toxic oxidative damage. Plus, selenium is absolutely vital for the deiodinase enzymes. Those are the ones responsible for converting your thyroid hormones into their active state. And because we get our selenium primarily from the earth, through our food, it leads to this fascinating, if tragic, geographical consequence. Get this. The actual dietary environment and the selenium-poor dirt you live on can literally shape your cellular machinery.
It can lead to a fatal heart condition known as Keishon disease. It's a type of dilated cardiomyopathy that was historically endemic to very specific regions, all because the soil itself lacked this one tiny microscopic element.
Finally, part 5, iodine, the metabolic engine. The way our body uses iodine is just a gorgeous sequential process. First, our thyroid glands literally trap iodide, pulling it right out of the blood. Then, an enzyme called thyroid peroxidase mediates the organification of this iodide, attaching it to proteins to synthesize our active hormones. And this entire magnificent pathway, it's directed from above by TSH coming from your pituitary gland.
But we really need to look at the deficiency states here because timing is everything. While adults who lack iodine suffer from goiter, which is that physical enlargement of the thyroid gland, and the sluggish metabolism of hypothyroidism, the stakes are so much higher early in life. A lack of iodine in utero or during infancy causes irreversible neurodevelopmental impairment, historically known as cretinism. This microscopic spark plug is just non-negotiable for building a functioning human brain. So, wrapping up this explainer, we've seen how lacking iron traps your oxygen, how missing copper wrecks your nervous system, and how absent iodine literally halts brain development. So, as you go about your day-to-day, moving your massive macro-level body around, I want you to ask yourself, are the invisible microscopic forces in your diet quietly dictating your entire physiological fate? Something to chew on. Thanks for joining me on this deep dive, and hey, keep feeding your cells what they need.